This class is the coding environment. Martin and Howard, you probably not have. Have you set up? I think you followed from the video lecture, right?
Yes.
So did you set it up? You Mac user, you already have Python, but editing. Which editor do you use?
Well, I saw when you in the slide you said to download Vector.
Okay, what? Yeah,
But
whichever good for you, you may be able to do that. Okay, so I think I can continue to go forward. So last time we did GUI, right? Graphical user interface. That is just the first step. So we'll come back to graphical user interface to do construct a frame and also menu. So two more things will be done. But before we get to that fancy, and also a little bit of animation. Michelle likes animation. Animation to us is I mean, the animation that we are doing, practicing here is very simple animation. But for even simple animation, you have to do a lot of coding, a lot of mathematics, right? You have to think at the time to move. One object needs to be moved to what direction, and when it could be bounced off, and which direction it could go, or something like that. How fast, and if they have multiple objects, how can you synchronize them? And a lot of things needs to be planned and implemented in real the language. There are a lot of other tools available for you to make fancy icons and engines to move objects that is halfway through made for you to simply use. But our concern is more fundamental. So that's what we are going to do. Before we get to that, we have to learn a little bit of logics, okay, programming logics. So depending upon the time permitted, well, without, in any cases, we will do conditional statements and then repetition. Those two things are, without those two things, almost impossible to do any logical processing. Okay. And in addition to that, if you want to make something continually, recursively, then recursion is another process. So we may consider that, okay, a little bit one step further. And then a lot of other application-dependent implementations will come when we do network operating systems and database systems. Then we will import some of the modules and add more values to it. So I want you to open Paizo. Those who do not have a Paizo, I want you to have I'm going to close all of this. Oh, this is something that we did the last time. Okay. Right? Or we'll do something other than this. Okay, if you want to open up new editor or file, then Control N, so that you will have new file. Those who do not have this title or Mac user may be able to do VI editor. That is very, very primitive editor on Linux and Unix operating systems. As you open your terminal, forward it. Do you turn on a terminal on your MacBook, or you don't know the terminal? How do you run Python then? Let me check which one that you have. Oh, Python. Oh, you have Python. Okay, great. Okay. Somebody that doesn't have. Okay, then you have this. Python has its own strength. One of the strengths is to string management, and another strength is to communicate with the external resources. Very easy to interact with the human user. Very easy to interact with the remote resources. So what we are going to do is that we're going to do two things, okay? Today. One, convert. What do you want to do? Convert, I think, the temperature. So if you give me temperature in Celsius, then our program will return you Fahrenheit, or vice versa. Okay? Then you need to first ask your user to enter a number, right? So you can say input, enter a temperature. So user may be able to enter. Then you need to receive it, right? Receive. How do you receive it? You need to assign user enter to a variable that you can define. So you can say user temp, and at this point you simply say print user temp. This user temp is the same as that you defined and hold the value entered by user. So that value needs to be displayed. The way that you display on the terminal, standard output, which is terminal here, is simply print. Okay? So let's start with this. two simple statements. Then you need to save this as a file. So Control S, then it asks you to choose the location. So I can choose the location here and in class, and I can say temp conv temp conv .py.
Actually, I turn off the light. Like there.
Please. A middle one. Thank you. Better? Is this too small? Oh, you can do simply zoom in and out. Okay, plus minus. So, for example, control. Is it good enough?
Yeah.
Then I cannot do much. How about this? No. I think this. Okay. When I need more space, I'm going to reduce a little later. So I saved it. So file name is temp conv, and this is case sensitive. Well, this itself is not. I'm not sure. This is Windows operating systems, not really case sensitive. But I rather do have case sensitive myself. So temp small, C cap upper case, and conv.py. So that is saved in this file, and the location that we chose, right? A specific location. So next time, if you want to reload this, then go to that location, and then maybe double click. Since it is created on Paizo, when you do double click a file, then already there is the bindings. So this one will be come on. Okay. Since this file is already chosen and decided, you simply execute it. The way that you execute it is very simple. Holding down Control button and hit Enter key. Then I'll put here, it says enter temperature. What is the temperature today? I think 80, 79. Then I entered 79 once, and it echoed 79. Why? Because I said so here, right? I asked to enter. I asked to print the value. I print the variable which is defined in line 1. This variable is just defined here, and because there is equal sign, 1 equal sign, the right hand side value is assigned to the left hand side variable. Okay, so in the right hand side you have input. Input is a function, therefore you have open parenthesis and close parenthesis. Okay. And this input function, if there is a string within double quote, whatever within this double quote will be written as is, as you can see here. That is written as is, enter space A space temperature colon, and then one more space. That's what I made here. One more space, therefore we have one more space there. And then your cursor is blinking right there. Right? That's what we did. Execute one more time. Now when I click here, then my cursor is here, which is one position after the colon. That's what we designed here. You cannot type inside. You cannot type anywhere. You need to type here only. That is what this function behaves. This function waits a value, the value that you need to enter. Right? But in this case, it doesn't matter if you it says enter temperature, but if I say this is my temperature, enter. This guy is not yet intelligent at all. So when user enter that, then simply echo the value like this. User entered this, then display that one. So right now we assume user enters a number, right number, okay? Now we need to consider the definition of conversion, okay? How do you convert? There are two different conversions, right? From Celsius to Fahrenheit and from Fahrenheit to Celsius. So the conversion, anybody here got the physics so that? No? Okay. The formula is this. If we have a Fahrenheit, then Fahrenheit temperature minus 32 multiplied by 5 divided by 9. That is in somewhere, right? And if you enter Celsius, then the Celsius needs to be multiplied by 9 divided by 5 and finally plus 32. You probably remember that, right? You probably have seen that formula once, at least once in your life. So we're going to use that. Formula is given, right? We do not ask you to find that formula. Who found that formula? Temperature conversion? I do not know, right? We do not really care, right? We simply use it. Okay, so let's assume in this simple program, user enters Fahrenheit. So we want to convert to the Celsius. Then the formula is this user temperature needs to be forced to subtract by 32 and then multiplied by 5 divided by 9. And this is my, let's say there's a Fahrenheit, so my Celsius cell. And then we can say here your temperature in Fahrenheit is my cell in Celsius. Save it, Control S, save it, and execute it. So if I enter 79, oh, what is it? Okay, what did it say here? You have to, the coding, first step of coding is to understand the error messages, right? Error messages are very, very important for you to improve your coding skills. Trace back, most recent call, last file. This file is called, right? This is the file. We don't have to worry about this, right? temp.conv.py. That is the file name here. Line 2. So line 2. In module, this is the entire file is my module. My cell equals that one. Okay? This is the statement that I made in the line 2. And then here is the error message. Type error. Unsupported operand types for minus string and int. What does that mean? So when user entered, remember that somewhere here, when I enter something character, it still receives the character. When I enter number, it receives the number, right? But actually, number that I enter, 79, that is to me a number, but to this computer, that is just character 7 and character 9. Like in this case, character J, character D, character K, character L. What does that mean? When user enter from the keyboard any value, that value is received as here str, string, received as a string. What is a string? String is a sequence of characters. Sequence of characters. This is a sequence of characters. Same thing. 7 and 79. This is not the value 79, but sequence of characters, which means 7, 9. So when user enter, that is a string. It is not yet an integer. Can you subtract integer 32 from string? Say Mercy College. I want to subtract Mercy College 32. You may do so, right? If you go to Mercy Hall, there's a boss office. Hey, give it to me my money back. That's not what I want, right? Or you can do whatever. Walking dog, Joe's dog. Subtract 35. It doesn't mean much, right? If you want to if you want to apply subtraction, then there should be two values, two numbers, right? Two numbers. The one that we have here, the one that we hold in this variable is right now string. Is not yet a number. So you need to convert that to a number. That is very simple in this case. This itself, the other way that you could do is in this way. The simple way is user temp equals int user temp. Okay, so two steps. So in this step, in the first line 1, we just received as is user temp, and in the second line, that user entered value is entered into another function called int. See here, if I do int 34, then that is int. It's not going to work, for example, if I do int. There's an error, right? But when I say int, this means this is not 56 yet. This is just two characters, 5 and 6. 5 and 6. I want to make this 56. That's what that function int can do. Okay? So, given a variable which holds a sequence of number, I want to convert that to, if I have 3 numbers, then hundreds, 2 numbers, tens, and 4 numbers, thousands, something like that. Okay, so that is this, and save it, and then we can put 70. Wow, it works now, right? So when I enter 70, your 70 in Fahrenheit is 21.1111 in C, in Celsius. Someone may ask questions. Can I put this in one line? Oh, Joe, you did?
No, I broke it.
Right.
I put it in one print statement, but I did /n.
Okay. If we want to separate print statements, but put them in one display, one line in display, then remember that print is another function, right? Print and open parentheses and close parentheses. In the last parameter to that print function, you can do and equal open quote and close quote, and save this and enter and execute it. Then let's say 79. Oh, very nicely. Your 79 in Fahrenheit is 26 in C. In one line, right? What makes 2 print statements in one line? This parameter, comma, and equal, open quote and close quote. Someone may ask a question, oh, can we make this a little bit, oh, this is a repeated number. Can you make this, I don't want to, I'm not that sensitive. I'm sensitive only 2 number below decimal points. That's very Americanized number system. Why? Because we have a dollar bill and then coins. Coins usually 2 numbers below decimal points, right? Not all the time. If you go to gas station, they have 3 numbers below decimal points, right? Gas price. Martin, what is the gas price these days? 245. 245 only? No.
Like 260. I bought gas last night. It was like 268.
268. That's it? Or 268.9? Gas station always put the 3rd digit below the decimal points, which is always 9. I've never seen, well, if gas price is 2.68, then 2.680. I've never seen that kind of price. always 2.689. Yeah. But anyway, can we manipulate that way here? How can you do that? This itself cannot make that. So what you need to do is, you have to do this very carefully. I want to break this. And then there is a open and close curly brace. And then there is another function associated with the print function, which is format. In this format, I can put what is my cell, okay? Dot format my cell. This my cell, if you have a multiple of values here, my cell and some others, two values are fed into the print statements, then you need to say, hey, this is the first one, and somewhere here there will be the second one. You need to say in this way. You need to say in this way if you have two of those, because you in this format function, you prepared two values actually, right? Then you need to indicate. If it is not the case, then you don't need to indicate. In our case, we don't need to. Only one, then you do not need to. It doesn't harm. So let's leave it. And colon. And then we need to specify, let's say 5.2f, whatever the number, okay? Dot 2 means here, I want to save only 2 digits below the decimal points. If you say 3, like a gas station number, then I want to save only 3 values, something like this. So let's try. So you enter 79. Is this format? Attribute error, non-type object, no attribute format. No attribute format? Let's see.
Yeah, I think you're gonna have it reversed. Like your numbers,
Where?
like the semicolon, if you instead of 0, it should be like colon F, and then what you want to do.
Do I have a semicolon somewhere?
Well, no, like.
Oh, here?
Yeah, it's like it doesn't need 0 in front of it. It's like what I'm looking at. It's like.
Maybe, yeah. If you have a multiple, then you need to say 0 and 1 and 2. Right? So in this case, simply colon. Okay, let's try. 79. Oh. Okay. Format, attribute error, non-type object has no attribute format. Print. Oh, I'm sorry. Oh. Yeah. This is it. Let's see another. Oh, the problem is this. Close, and at the end, here, this should work. I'll put it back. Okay. So format is a function available to a string, not associated with the print function. You know what I mean? So print function covers from here to all the way end. And this dot, this function is associated with that string, with the double quote. That should work. So enter. We can do 79. Oh, very nicely, right? So enter that your 79 in Fahrenheit is 26.111 in C. So you type anything. In summer we might have 94 degrees, then that one. I don't know why all the same numbers in the floating points. 93. Oh, that's different. 889. 92. 333. 91. 778. 90. 222. Strange. 67. This is format like that. Okay. Now, what can you do further? So from here, a lot of extension possible, right? I want to make not only the conversion from Fahrenheit to Celsius, I want to make it selectively. But before we get to that, I want to make this as a function. I want to define this as a function, which means define Fahrenheit to Celsius, and by receiving Fahrenheit number, what does that mean here is I'm going to put that in somewhere as a separate function. Okay. Let's see. Do this. So I'm going to receive F make this, and finally I want to return my cell, then here my cell is received from that function F2C. That function takes my temp here, so put my temp there. I changed a little bit. I changed here this part, right? Previously, my cell is directly the computing. That is the outcome of that computation result and assigned. But here in this case, this my cell received number from this function call. I call this function like input, then I call input function. When I print, then I call print function. Just like that, I call this function F2C. All other input and print functions are provided by Python. Not only the functions provided, but also the function that I defined can be used by myself, right? So I defined here. When you define new function, then there's a function name. By the way, we need to have def. This is by having def, define def. My Python program understands, oh, this guy wants to try to find a function. So what's the following? Def is the function name, and then because this is a function, then open and close parentheses, and if there is any variable, then this variable is nothing but the variable the caller function entered. At the caller side here, F to C, open and close parentheses, the parameter here is user temp. By the way, user temp is given by user, right? Okay. And then, so that is, user temp here is nothing but here F. That F needs to be converted to int. That F, before we compute, that needs to be converted to F here, right? And then same formula, and I received it, my variable, my cell, and return that variable. So when it comes back to the main program, once this is done, then return value should be assigned to left-hand side. Fortunately, they are the same variable, but not necessarily, which means I'm going to say here my cell, different variable, that's fine, right? This is a local variable here, my CL. But this my CL, when it come back to the caller program here, main program, then my cell is assigned to, my CL is assigned to my cell. My cell is therefore used to here. Let's see how it works. Save it. And I'm going to put 79. Oh, there's no difference at all, right? So this is, what is the point here? Point here is that modularized. I make this as a separate module, and this is my function, right?
And you said when you delegated from one function onto another?
We can do that. We can do that too, right?
And
Yeah, function can call another function and another function and another function. Finally, that function may return the value. Then in your main program receives it and do further. That's whole point of programming. Not only that, when this guy calls my program, okay, my function. This is my function. This is the function that I defined called F2C, right? F2C. For some reason, I may call myself. When I call myself, then it come back to me, myself, and then it call myself again, and it call myself again and again and again and again. So that is a recursive program, recursion. So very, very long line of call procedures can be done in one short statement. That is a recursive program. But that's something. Okay, so this is a module, one module, separate module. Which means before it is called, if you have this, you can do this up here. Because this is just separate module. Okay? This highlighted one, this is a block, this is a module. So real logic is from this, except definition of a function. The real logic in this program flows from line 1 and line 10, line 9, 10, and 11. That is the flow. This is simply module. Module can be placed in anywhere as far as, well, in this case, let's try it. If it works, right? Same one, 79. Oh, perfectly fine. What about I relocate this to the end?
Can you try another number?
Huh?
Try another 92.
Sure. So this is a main, and this is defined later. Okay. Fine. This is a separate module. So Python is a good language in this way. What happens here is that Python reads Python engine, read my source program, line 1, line 2, line 3, line 4. When it read the line 2, although it is unknown, at the first pass of reading, it is unknown, right? It is known when it reads all the way to the end. So at the first pass, this Python mark, hey, F2C is now unknown. I need to come back if it is known or forever unknown. In the second pass again, when it comes to this, oh, I read it from my first pass. So in the second pass, realize that. So this Python program executes at least to 2 passes. Some dummy language pass only one time. If the language, the engine passes only one time, then you have to be very careful. Everything needs to be defined up front if it should be used. So when it comes to this main logic, everything should make sense. Like this, F2C. If this is defined up front, then your compiler, your interpreter, understand it because it read it already, right? This is something else. This is the language issue. Okay, when the programming language defined it, it implemented it that way. 1 pass language, 2 pass language, 3 pass language, or multiple pass. Therefore, for example, Linux shell programming. Linux shell programming is usually, if I remember, a 1 pass. So you have to define everything up front before you get to the main logic.
So what if you don't want to be so structured? You don't want another programmer to look at your program, your code, and actually...
That is possible. In that case, you have to do import. You have multiple programs. They are all the different modules. So you have to import so that everything, all other third party, including your program, can be imported into this playground so that they work all together.
So like that, he can't tell where everything is going in one shot and how the program is reading within the model, correct?
Correct. All right. So let's make it a little more. The convention of this is, let's assume this is not two-pass language. Then anything that you need to define first, and then what's following is the main logic. How about that? Okay, that is a convention. Okay, in this way, you do not make a big mistake at all. The other way, fine, but this looks better to everyone, to every language. Okay, the habit of coding in this way, if you do, then it works for others also. Because you have one definition of function, which is the conversion from Fahrenheit to Celsius. Now you could do the other way, from Celsius to Fahrenheit. Then you can say, oh, this is a C to F. And then it receives C, right? And then this should be C also. By the way, oh, then I need to do all here. Whenever this value, user temp, either it goes to this function or that function. I have very similar statements appears twice or more, depending upon the similar functions to be defined. To make it simple, why not we convert here before we send it to the sub-function? That's possible, right? I want to convert this. By making one conversion, anyway, either it goes here or there or another, it is already converted, so we don't need to repeat this again and again and again, right? So let's delete this. Let's delete this. I want to, either you can convert here or you can convert here. Watch this. Input and all the way here. This is a little complicated, right? Double parenthesis. So look at this highlights. This highlight is the language that we had, right? So input function returns user value, right? That user value will be the input to another function. Function is int function. So the integer finally assigned to user temp. So user temp is not anymore string, but in this case integer, because before we assign, I pass through the int function, and then it calls further. In this way, we can make the function simple, right? The coding wise, not really the execution. The coding wise, it's simple. Okay. Celsius. This is my. So now it is not necessarily my cell. We can say my temp, my T. My T. You can say my T. And this is my cell. This is my Fahrenheit. My Fahrenheit. This is not user temp. This is simply C. And this is F. Right? And we'll touch this function. Function is not this, right? Function is Celsius. If Celsius is given, then the formula we need to multiply this. First multiply by 9 divided by multiplied by 5 divided by 9, and then finally plus 32. This is a formula. This is a conversion formula. This is a formula to Celsius. So formula to Celsius, a formula to Fahrenheit. Now there is another issue. When user enter the temperature, we need to ask user to certain form so that you can say number in number followed by F or C. Okay? You can guide this way. So for example, we do enter temperature in number followed by F or C. Then you can say 79 space F or C. Something like this. Enter, but in this case it doesn't do anything. But or you can say enter a temperature. You can guide nicely. For example, 79 in Fahrenheit. How about this? For example, 79 Fahrenheit. This makes more sense, right? Right. Oops. So, all right. So right now the problem is, if you enter 79 and C, then we cannot convert that to int. That is another problem, right? So let's take this out here. Int. So a lot of things. So take the user temp right now, and then we have to do a little bit of the cleaning process. User temp needs to be split. There's a function split. If you do not have, if you put any function, for example, when user enters 79 followed by C or F, in between, if you ask user enter colon, then you need to say colon here. If you ask user enter comma, then you need to put comma. Or if you ask user leave blank, then leave blank. So by blanking, and then you can say my user input. I want to put that in user input, and for a while, let's see what user input is. Okay. I know there is some error, so let's make this comment and see what happens. Let's run, and the user enter, for example, 79 Fahrenheit. Enter. Aha! When I use this as an input, so whatever user enter this 79 space F. That's user temp. That user temp has another function associated with itself, so we call that function split. Split function open and close parenthesis with no parameter means white space is the delimiter. So there is a white space. So two values. Therefore, we split that, and those two values are in list. Square bracket in Python is a special data type in square bracket. So we have two strings. See here, quote 79 and quote F. Two values. Let's try one more time. If we do 79 F, I am a boy, for example. See here, when I type 79 F, I am a boy, then after this split function, the outcome of this split function is a list of all the values split based upon white space. Therefore, we have so many elements in this list. 79 in quote, F in quote, I in quote, am a boy. Right? This is something that you need to control later, saying that if user enter more than 2, then you need to say, there is an error. Okay? Something like that. But what I'm saying is that even if you user enter multiple series numbers, as we did here, right, in this case, it can be taken care of by the function split. So this is a list. My input is a list. So user I would say user in rather than user input. User input is here, right? I'm going to back this, right? And user input is therefore user imp and the first element. First element is user input. User, I would say user value. Let's say the user val. And then second element unit indicator, unit ind, that is user imp, which is in the second. So that you can say here user val, this should be user val also, and this should be user val. Everything should be, when you change the user val, double click this, then you can say, oh, they are all changed. My t, my temp, my t, or here. So my t is received from this function. So that makes sense. Okay, so you can say here print in unit indi. I don't like that one. Okay. So user indi. So user indi, unit indi, that is this. Okay. So save this. Let's try. So even if you say 79 and F, you are a equal what is it? Oh, here. So here we need to, before it and this should be integer, right? So you need to put here int. You need to convert that to int because that is number 7 and 9, not 79. Therefore, you need to convert it to int. That's what we had the previous error, right? So here you can say also 79F, we are in Mercy. I said the 79F, we are in Mercy. Previously we have a lot of this, we are in Mercy. This should be an error, right? But there is no error. Why? Because I took only the first element and second element. I do not care the rest. Although somebody says, you are very, whatever it says, whatever follows, I ignored. The only one that I took from this that is this. For example, list equals, in quote, when I do this, quote, put, comma, quote, quote, comma, quote, quote, comma, quote, quote, comma, quote, quote, comma, quote, quote. That is this, LST, right? 79F, me, we are in Mercy. But when I do LST, the first element, there's a 79. Second element, F. Those two things are my concern. So first one, because this is a quote 79, so what I did here is the int LST when I turn this function int, okay, then it gives me 79. This is a 79. This one is quote 79 string. This is the point, right? What it returns here is just a quote. So I convert that to integer like this. Second one simply doesn't matter that. If you have so many elements in one list, this in one quote, like this is one quote, right? One element, one list, unknowingly many elements. If we want to access all of those, then you need to have iteration for loop. But there is luckily there is a function called len, like a function int or function imp or function print. There is another function available, len. Len takes list. Our list is lst. Then it returns the number of elements. So it says 6 elements. How many in LST? I have 1, 2, 3, 4, 5, 6. Yeah, therefore it returns 6. For those 6 in list, if we want to print each element in one single line, enter, then it says 79F, we are in Mercy. This program, short program, did this, right? This is for loop statements. This is iteration. We're going to do a lot of this practice, but this is the first time to somebody here. So what it does here is that, look at this. For, this is a reserved word. In, there is a reserved word. Anything that you hear a little bit in bold face, that is a reserved word, which means you don't need to define FOR. This is already known. This is a language. In, that is also language. There is a plain text, ELE, that is our string, our variable. LST, this is our variable. This LST already defined here. So this guy understands what LST means. And this ELE is a variable that I need every time when I look at the element from the first element to all the way to the end, each element I call it ELE. You can call it some other name. If you call this ELE, then use that ELE in print statements. So what it does here is that, given this list, I want to take into consideration each element at a time. Element means anything in between comma. So this is the first element. Take 79 and print. That's what we did here, right? And second element, print. Third element, print. And fourth, all the way to the end. In these statements, we do not need to worry about how many there are. How many? Doesn't matter. If the user enter hundreds, okay, we'll take care of the hundreds. If the user enter any number, right? This is very simple, right? It's not the for loop like in Java, for example. For I equals, for integer I equals 0 to some number every time increased by 1, right? Yeah. Java has also this similar language, for each. This is exactly that one, for each. You can read these statements. Listen, everybody. You need to read these statements as follows. Whenever you see this, for and in, then you need to read as follows. For each ELE in LST. So you need to put here, right after for, you need to say each, EACH. So for each ELE in LST, that ELE is printed. This is also a side story. Okay, let's come back here. So what else do we need to do in this temperature conversion program? Joe.
I don't understand. Like your ISO is running that way, and every time I try to do LST on mine, it says it cannot find anything. I don't get it. You're like moving so fast, and I'm trying to keep up, and I'm like, I just don't understand. Like, my iPad has no in and out.
Hold on. Did you do this? I typed. I typed explicitly. I typed and then I showed.
We're all like kind of lost back here.
You need to stop me.
Oh. Now we're good. Good. It's like, we're all like three of us. Like, where are the edges?
Yeah. So there's no fake in computer. If there's something, then there's something already prepared.
You get your decaf.
I want you to practice that. The one that because some of you missed it. Remember this? This is separately done. Okay, this is a side. I did this, and then practice that follow. I want you to try. For this reason, sometimes we need to do minimize, right? I want to minimize this so that minimize more. Okay. This is something that I did. So let's take a break. All right, here. So question about this. Question about these three statements, which is evolved from the earlier simple version. The logic now evolved is to have two values from user. Not only one value, but two values, right? One value in number, the other value for indicator. So we can say, oh, I want to convert my temperature because I'm from Europe, we use Celsius, okay? So 32 Celsius. What is your temperature in Fahrenheit? Or vice versa, right? So we either this or in Celsius. In between space. Then we need to get two values, two different values, right? Two different values to cook. Two different values. So one value is called the user val, the other value is unit indicator. Right? So how can you get two values from one input? Actually one input, but anyway there is two values, right? How? We need to split it. Split what? User value, user temp here. When user enter value, then it is received by this variable, user temp. That user received variable needs to be, user received value needs to be split. Split based on what? Nothing. Because I didn't say anything. But if you say, comma, for example, alright, then come back here, you need to say 77, comma, F. That way it works, right? When I say 77, comma, F, this guy understands. I want to split user input value based on comma. But if I don't do anything, and if I do 77, comma, F, then I have an error, right? Should be an error because it is not what I designed. So everything, the logic and user needs to be is based on strong agreement. User needs to follow the way it is programmed. Okay. That is a typical programming. Now, intelligent programming is a little different. Because it is so-called intelligent, then it should take care of, right? Whatever my answer dummy. But right now, at this stage, our agreement is that user needs to be smart enough, or on the other hand, the program is dummy. Therefore, user needs to be smart. The program is dummy, so program runs only if it enters in this way. So user needs to be so smart. So user needs to take care of all details. So if in this case user enter, let's say 99, comma, F, that it enters, right? Okay, so this is a split. And the next two statements. If you see next two statements, when you do split, then somewhere here. Okay. Do we still have LST? Oh, we still have LST. Okay, what I want you to do it in this way. Somebody said, hey, can you split me? That's a string, right? And then dot split. Then it returns this list. Okay? So if I receive this, my val equal. My val is now this. This is the same as before, right? This is a string. From here to there, there is a string. That is exactly the same as this. Because anyway, user enter multiple values. User temp here is nothing but highlighted here. I hard coded there, but here user interactive. So when it comes to this hard coded string, then hard coded string can be split. The way the string is split and returns is a list. Each one split based upon white space. See here, hey, comma, they're all one string. From here, they're one string. See here, there's one string. Instead of a comma, instead of a white space, we can say, oh, this is what separate element. This is another element, and this is another element. Comma is just a delimiter. This is another element. This is another element. So we assign this into my own variable. I call it my val. Okay? I want to do like this. I want to put some number there. So what is my val? Now this. Hey, 34, because I get 34, and the rest remains the same. So this is my val. This is the outcome of this. So we call that user input. From this user input, why don't I call it user input rather than this? I want to make imp. So user imp is like that. The first one let's make real the same. Rather than this, 56 F and hey. So user input is this. First one is 56 in string. Second one is F, and the rest that. Okay, just like this. But I want to. This statement is. I want to see user inp is that one, user imp. That is user imp. I want to extract the first element, second element, and third element. First element can be first element is this, and second element is this, and third element is this. What I mean by that? Element in a list square bracket can be accessed by index number. So index number start from 0. The first element is pointed by 0. Second element is pointed by 1. Third element is pointed by 2. So on and so forth. That way, right? First element here, 56. Second element, which is index 1, F there. Third element, which is index 2, therefore hey, that came out. Now, hold on. Okay.
Can you start it from 1, 2, 3 instead of 0, 1, 2? Will it still pick it up?
Always it starts from 0.
0, right?
0, 1.
That's all.
Like Java or C.
0.
Okay. Now, Chris, you have to listen to me. Second element, this indicator, Fahrenheit F, okay, because that's an anyway character, right? First element, 56, that is also in character. If that number remains as a character, then there is a problem. Problem is the computation. Character cannot be computed. Computed, for example, multiplied by 5, divided by 9, plus 32. You cannot do that. It should be a number, integer, right? So there is a function called int. Like this, if this is a because user imp 0, as you looked at here, that is what I expect as a number, but it turns out it is not. It is still string. So I need to change it to integer. How can we change to integer? We need to use a function called int. So this is a function, int, open parenthesis and close parenthesis. Inside the argument is this, 56. When I do this, it returns 56. Compare this 56 and this 56. This 56 is in quote. That's not a number. That is the reason we need to put here int. The other one, don't care, because that's what we want, right? Did I answer to your questions, Chris? Bonnet? Can you explain to him?
I was trying to type in everything you said.
Yeah. Can you explain that to him? I want to.
Anything detailed, but I think I got it now.
I know, Chris, you understand, but
It was just that the user, when the last two, the user allowed outside of can extract the first element, but you don't have to put the int with the unit id right there by unit user int. Yeah, the second one, you don't have to put the int.
I don't need to. Or if you want to, you can. If you want to put all in one line,
Yeah,
yes,
that was
you
my-
can.
Yeah, that was like my biggest problem.
Right.
I didn't know.
But if you don't do, for example, did I do that? Right. If I run that, say 79 and F, I want to make this, right, this separately from this. This is one single statement. This is another statement. But if you want to put this into the previous line, if it makes sense to you, then you could. But because it is not, therefore we didn't put that there. Right? If I don't put this, then each one separate line. So let's run this one more time. 45 Celsius. When I say 45 Celsius, it still says your 45 in Fahrenheit is 7.2 in Celsius. But I put 45 Celsius. What is the problem? Problem is that my program is not, my program does not compute selectively, right? My program always calls Fahrenheit to Celsius. Right? So what should I do? Depending upon F or C, depending upon the indicator, I need to call different function, right? Do you understand? So let's do that. So having this, I want to make here some space. So far this is good. But only now a problem is we need to call selectively. So I need to see if unit in the is F or unit in the is small f. Now I take care of user, right? If user put lowercase, I still take care of it. Right? If user put uppercase, you are fine. That's what I did here in all statements. If user enter uppercase F, okay, I will do. Lowercase, no problem. Also. If it is if Fahrenheit number is given, then which function needs to be called? Fahrenheit to Celsius, right? That's what I need to call. That's what we have here. So I'm going to copy it there. I'll remove this. Or I can simply put here. Oh no. Where's the previous print? I want to make sure when user enter, then I can say you entered user val, which is this, in, this is what I want to display as is, and then finally what user put the indicator. Okay. This. If this, then we call that. Else. else, whatever else, then my t equals c to f user val. And this is not any more that, and you need to put here so your I already have it here, so we don't need to do this. Right. That's okay. Your value in this indicator is this in something else. Opposite. If F is given, then we need to say C. If C is given, we need to put his F. You need to make it a little intelligent here. Okay. So little more intelligent. There are many ways that you could do, but in this case we do it this and this one. I need to put here comma. How about this? Okay, let's try. So let's see, 79F. You entered 79 in Fahrenheit. That's fine. Your 79 in Fahrenheit is 26.111 in Celsius. Oh, so nice. Try one. And we can say 23 Celsius. It says you entered 23 in Celsius. Your 23 in Celsius in 44.778 in F Fahrenheit. Wow, intelligent. Key point here is that when it comes to F, okay, we call Fahrenheit to Celsius function. Also, we change the converted indicator to C from F. Else, we call different function, and therefore converted indicator also opposite. Okay. Now the problem here is that, let's say 23, I can say it's 23 whatever. 23 whatever. Okay. I entered 23 whatever. So what? I put this. I'm so bad at user. 23 whatever, so what? Enter. Oh, this program is you enter the 23 in whatever. your 23 in whatever is 44.778 in Fahrenheit. Funny, right? This is not what we want, right? So we have to do a little more. Here, we have to, as if unit in the equals C or unit in the C, and then one more here. Finally, else you can say print we'll just take care of it. When I say, as we did previously, 23 whatever, so what, and it says you entered 23 in whatever, your unit is illegal, goodbye. Right. So, what we need to do is, this guy needs to be this guy needs to be inside this and that. But if I make this copied, double waste of space, right? How can you make this more efficient? If, as if, and else. Another way that you could do is, instead of this, we type this, okay, with that, and this one needs to be in here. So we don't need to do this because we already know, so we don't need this. Sorry, a little bit confused, right? Because I keep changing. So F here, we simply say F. We don't need to convert. We don't need to do this. Save. I think this looks okay. So if we do 23 whatever, so what? Then it says, you entered the 23 and whatever, so what? Your unit is illegal, goodbye. No computation, goodbye. \n in string means I want to make it a new line. So when you do this, same thing, 12 whatsoever. Then it says your 12 in whatsoever, your unit is illegal, goodbye. I want to make next line. This is the thing. These statements, these print statements, wants to the next statements to be combined, right? Joined together. So whatever here is joined with the previous print statements. So this should be joined also, unless I do have this. Therefore, without this, they joined together. Here I said join. Here I said no, I want to separate. Therefore, this became separate. So if we run another 34 Celsius in small c, right? Small c. This still works, right? Your 34 in. If user enters small c, I use small c also. Is 50 degree in that. Somebody has any question?
Do you still need to have split in there? Professor? If you're using else if else, do you still need to have split up top? User 10 dot split.
What is your question? Question again? I know which ones. So here.
Yeah, do we still need to have that if we're using the else if? I mean.
Oh yeah, this is because the user entered two values.
Okay.
Two values, therefore we need to split.
Okay.
Okay, now the degree, I want to put here some degree, 34 degree, or like small circle as a superscript. If we print, this is a what is that? Universal Unicode. Unicode 00B0. Do you see here? That is the degree symbol. How can we use that? We use that here is here we can put backslash u 00B0 there. let's see. So if user enter 45C, your 45 degree in Celsius is 57 degree in Fahrenheit. There's space, we cannot do any further than that. Only the way that we could do is, if we do not like that, then same thing here, you need to do (5.3f) in 1 0 user val comma di. This is nice. And then this is repeated. So what I want to do is how about this? Zero, 1, 2. No, it is not. Because this should be computed here. Okay, let's run. So 12 and Celsius. Oh, there's an error. And value the format specifier. So that 0 and 1. It's not like. What is this? Is it in the format specifier?
It should be 5.3 instead of 5-5/3.
Oh, I'm sorry. Who did that? Oh, thank you. Right. Okay, here 34 Celsius. Okay. Oh, now this degree is attached to right after to that number. In the previous, we have some space here, right? So what it does is that what it turns out is if we have this kind of if we use a format function, then output will be more manageable. I'm not sure you understand that. What we had previously, I want to compare this with the following. What we did previous is I put your and then user val in then I can say unit ind, comma, end equal quote and quote. This is what I did, right? When I do this, I open this and I'm going to comment this out. When I run the previous version, and this should be here, right? When I run this 12 Celsius, then I have here space. But if I comment this out and take this in, save, and run here, same thing, 12 and C, then I have here 12 space degree in C is that your 12.000 degree in C is the more homogeneous, right? In temperature wise. We need to do a little more. What else can you think to improve this program more intelligently? James, you want to say something? What about this? For example, when I do this, I said 88 do not ask me. It says 88 in 2, your unit is illegal, goodbye. Rather than goodbye, then how can you guide the user more enforcefully? We need to ask him again, right? Again, until user enter the answer and right answer, right input value. What should we do for that? Yeah, we have to make it a loop, iteration. We're going to loop next week, but I'm challenging you. Okay. So think about how can you make this loop. So until user enter the legal value, and until your system serves the user properly, completely, there's the Apple spirit, right? Apple customer care. So your program is to care the user for 100% satisfaction. Well, that's not the Apple, but ideally. To make it, this should be a loop. See, rather than say goodbye and re-ask. Make sense? That's a program evolution. There's a lot of things that you could add more and more and more. After we do this, what do we need to do? We need to put this on graphical user interface. User click number, and you have to make it really nice. Actually, that is in the textbook, right? can try it right now. Iteration. Guide the user to enter the proper input values. Continue on. So I'm going to leave this onto you, and because we have still have time, right? Still have time, but I want you to challenge it, and I know you.